Okay, here we go. Law of cosine. Even though we're doing law of cosine today, I'm going to do a little bit of review with the information about law of sine. What is the law of sine if we happen to use it during today's lesson? Cool. What information do we need? Thank you. What information do we need to be able to apply or work through the law of sine?
That angle and its opposite side.
So we do need that angle on the opposite side. How would the information be given that would put us in that situation of possibly starting or needing to start the question off by the law of sine?
Angle, side, angle.
So we got angle, side, angle, which is a congruency theorem, so one triangle.
Or angle, angle, side.
Or angle, angle, side,
Oh.
which is also a congruency theorem. That's what I want. Or side, side angle, which is the ambiguous case, which is where you open the door up for having 0 triangles, 1 triangle, or 2 triangles, which we will revisit that probably tomorrow as we review, not the one we were talking about yesterday. If you go to find an angle measure using law of sine, you will at some point be typing into your calculator inverse sine or arc sine. Arc sine, and that will be an opposite leg of some, fundamental reference triangle over hypotenuse. I'm writing this just to remind you of what you put into an inverse sine function, though we are working with what? Oblique. With law of sine and cosine, we're talking about oblique triangles, non-right triangles. But at its core, somewhere in a proof somewhere, there is the use of right triangles and angles. What angle do you get? What kind of angles do we get from arc sine? Greater than, theta will be greater than or equal to negative 90 degrees and less than or equal to positive 90 degrees. Now, as we find measurements of actual triangles, there's no such thing as a negative measurement. It might indicate direction, but you're only going to be looking for angles that are between theta being between 0 and 90 degrees. In that section of law of sine, there was a formula given for the area of a triangle. Now, there's 3 formulas for the area of a triangle. We have the old standard 1/2 base times height. If we don't have a height of that triangle but have enough information to find that height, which would be in the form of an angle in the triangle, we have an area formula, which is what? 1/2. A times B times the sine of C. Now, there's arguably 3 versions of this. It's 1/2 the length of 2 sides times the sine of the included angle. So if you say it in plain language, then we don't need to write 3 different formulas. Now, for law of cosine, your law of cosine is, so a squared is equal to b squared plus c squared minus 2bc times the cosine of a. There are 3 versions of this formula. Again, if you say it, though, as a side squared is equal to the sum of the other 2 sides squared minus 2 times those other 2 sides times the cosine of a, or cosine of the angle opposite the side that this equation is set equal to. There's only one version. All your law of all of your law of cosine formulas start and end with the same letter. Yes, I'm talking lowercase to uppercase, but it's still an A, right? It's still either going to start with A and end with A, start with B and end with B, or start with C and end with C. What information do you need to work to be required to start the problem with law of cosine? Or
3.
there you go. To do law of sine, you're going to do law of sine if you have all three sides or two sides and an included angle. That translates into two congruent theorems. What are those theorems, ma'am?
Side, angle, side, and side, side, side.
In the same order, too. Nice. Side, angle, side, and side, side, side. Both of these are congruency theorems, which means that's important because that tells you that there's only one triangle. And we don't need to basically think so hard when we know that we have only one answer as opposed to that ambiguous case of SSA. Okay, that's awesome. If you need to find an angle measure using arc cosine of adjacent over hypotenuse is going to give you theta. Theta is between 0 and 180 degrees. Oblique triangles can have what kind of angles? Obtuse. That angle opposite the largest side may be obtuse. Please make sure you find that largest potential angle using law of cosine. If you try and find an obtuse angle with law of sine, you'll get an angle that has some similar characteristics like equal reference angles, but you will have the wrong angle. At the end of the period, if I have time, we are going to be finding the area of a triangle. In a third setting, we don't have a base and a height. We don't have an angle included between two known sides. We only have information given in that side, side, side pattern. If you go to find the area of a triangle where you only know the three sides, if you can work around this set of formulas, but it's going to be a lot more work. When you know three sides of a triangle and you want the area, you're going to use something called the Heron's formula. And Heron's formula is a two-step process. First, you find S.
S is 1/2, and then parentheses A plus B.
S is equal to 1/2 A plus B plus C. It's half the perimeter. And then once you know that value, which is half the perimeter, you do the second step, which is to find the area, which is equal to what, sir?
S, and then parentheses S minus A, S minus B, and S minus C.
Awesome. So we should have time at the end of the period to work that out. We want to solve the triangle with the sides of A is 6, B is 4, and C is equal to 3. Well, what's that? Draw a picture. And it's side, side, side. It's that congruency theorem. So we're going to draw a picture, which you should do with every question that involves any level of geometry at all. So we have A, B, and C. A is 6, B is 4, and C is equal to 3. What angle would we like to start with, Ms.? You want to find angle A, B, or C first? You could find B first. B is not opposite the biggest side, though. So you could argue, I mean, you can find any angle you want first. But a lot of us, and especially if you see this example, I think some of us are going to want to, the law of cosine has what? You've got three terms that have powers of 2. You've got 2 times b times c, or negative 2 times b times c times the cosine of A. You've got a lot of math going on in your law of cosine. Whereas the law of sine, once you decide what two parts of this you want to work with, it kind of like just looks like, I don't do cross multiplication for these problems, but it kind of looks like just cross multiplication. So some of you may prefer to use law of sine. It goes a little bit quicker. So why not find that angle that may potentially be obtuse first? And then if you want to switch into finishing the problem with law of sine, you can. Or you can do law of cosine for nearly everything. So let's take that, Tori, and let's start working on how to find the measure of angle A. So 6 squared is equal to what? 4 squared plus 3 squared minus 2 times 4 times 3 times the cosine of A. Good, thank you. These are not going to be unit circle problems, so you're going to need a calculator. We do a fair amount of mental math in class, like we usually add and subtract mentally, which I'm going to be doing today. Again, but you can do 6 squared is 36, and whoops, 4 squared is 16, and 3 squared is 9, and you can do all this math, but it's kind of unnecessary. Now I'm going to tell you one really common mistake I see students do is they see all these numbers in front of cosine and just smash them all together and say, you know, it's something.
No good.
Why not? It's not good. I did say it was a common mistake. What's wrong with that? If I put all this together and say there's one number times the cosine of A, what's wrong with that? I see that all the time.
Well, 2 different terms.
Yeah. Multiplication happens before addition and subtraction. So you can do 4 squared is 16 plus 3 squared is 9. You can say this is 25, but please do not then do 25 minus 8 times 3 is 24. Do not do 25 minus 24. You are subtracting before multiplication, and you are not following the correct order of operations. So we're not going to do that. And since we have these, you know, fancy calculators that let us type in fractions that look like fractions and exponents without crazy, ugly syntax like, you know, 15 years ago, let's just subtract both sides by 4 squared, subtract both sides by 3 squared, and have 6 squared minus 4 squared minus 3 squared is equal to negative 2 times 4 times 3 times the cosine of A. How do you undo multiplication? Division. So we have 6 squared minus 4 squared minus 3 squared over negative 2 times 4 times 3 is equal to the cosine of A. And how do we get the angle of A out of the cosine function? Inverse. So then A is still exactly equal to the inverse or arc cosine of, okay, I'm tired of saying all the squares, 36 minus 16 minus 9 over negative 24. But arguably, I'd say that's probably rather silly, you know, because what if I just did some mental math wrong and I wrote 25 instead of 36? Then when I go to type it in the calculator, I'm going to have the wrong answer even though I know exactly what I'm doing. But A is going to come out to be now approximately, because we're going to round off, and just the nearest tenth is fine. What is the measure of angle A going to come out to? Cool. That sounds good, and it is correct. 117.3. Okay, so now we know the measure of angle A is 117.3 degrees. Where are we going next? Let's do law of sine. We found the one obtuse angle, and we actually got the obtuse angle that it is because we did inverse cosine. Do you want, now why can we do, it's correct, why can we do law of sine now? Yeah, we have an angle in its opposite side. Now the door's open to finish this question however you want. You know all 3 sides, you know 2 sides and an included angle, you can finish with law of cosine, or you know that side and opposite angle, so the door's open to do law of sine. You want to find the measure of angle C or B? Doesn't matter. B? Okay. So let's find the measure of angle B. Tell me how to do that. So 6 over the sine of 117.3 degrees is equal to 4 over the sine of B. Now, it is only maybe 2 extra steps or 1 or 2 extra steps. If you want to write this law of sine so that the variable's on top, there's only 1 fraction on the left and only 1 fraction on the right. And when you have 1 fraction on each side, you can just flip both sides. So if you prefer, you can write this as the sine of 117.3 degrees. This is not required. You could just cross multiply up in this line. Over 6 is equal to the sine of b over 4. And undo that division of 4 by multiplying. So the sine of b is 4 times the sine of 117.3 degrees over 6. And then b is the inverse sine of that. B is going to come out to be approximately, anybody want to give me some help? How about 36.3 degrees?
Yep.
Right off the top of my head. Or the solutions guide. So b is going to come out to be the arc sine of this value. The angle b is going to be 36.3 degrees unless I have some kind of arithmetic error in my solutions. So, which is possible. I hope not, but it's possible. So b is 36.3 degrees. Now, how do we find the measure of angle C? Cole.
180 minus 117.3.
Yeah. So the measure of angle C, we know two of the three angles now. We can just take those two angles out of 180 degrees. So we have 180 minus 117.3 degrees minus 36.3 degrees. What's 180 minus 100? 80. What's 80 minus 10? 70. 170 70 minus 30? 40. 40 minus 7? 33. 33 minus 6? 27. And 27 minus 0.6? 26.4. Nice mental math. Now I forgot what it was. 26.4? Okay. And we have solved the triangle. Exactly. Okay, perfect. Nice job. That was fun. Okay. Well, you started, yeah. I should have presented that problem better. But I also kind of let your questions get me stuck. But I should have, we'll revisit that one because it is kind of a fun problem. So in example number 2, can we solve this triangle ABC or ACB?
Well, yes, once you find the angle.
Yeah, exactly. So come on, Mr. How do we find that obvious statement, that obvious angle? What is the measure of angle ACB? And by the way, I have to use 3 letters because there's 3 angles up here. Just saying angle C is arguably kind of not really correct. The measure of angle ACB, how do we find that?
180 minus 15 minus 35.
180 minus 15 degrees minus 35. So 180 minus 10?
170.
170, now minus 30?
140.
140 minus 10? 130 degrees. Okay, how is our information presented to us in this question? What pattern do we have? Angle, side, angle, 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 side, SSA, side, angle, side, 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 side. How is this information given to us? Bam. All right, so we know a side, an angle, and another side. And so our information that we have now with a little bit of distance help is side, angle, side, which is a congruency theorem, which means we have only one triangle. This is not ambiguous case. Will we start? You need to get, for this point, Miss C, you got to help me get started a little bit farther. How are we going to set this up? What part of this triangle are we going to have to find first? We kind of don't have a choice. You have, now that we know that the measure of angle ACB is 130. Beautiful. So the side of C is opposite angle C. So tell me what to write, ma'am. C squared is equal to A side squared is equal to the other 2 sides squared and added together. So that's going to be what? So give me some numbers.
Oh, sorry.
8 squared plus 13 squared.
And then
Minus 2 times 8 times 13. Measure of angle C, which is 130 30 degrees. Excellent. Nice job. Okay. So again, this is a calculator-based question. Again, do not, actually, there's no reason to really literally do anything other than just type this all in the calculator at one time. This is already solved for c squared, so how do we get rid of the power of 2? Square root. So c is equal to, and then just, you know, for better or worse, we have these calculators that let us type in exactly what our expressions look like. So the square root of 8 squared plus 13 squared minus 2 times 8 times 13 times the cosine of 130 degrees. Just type that in your calculator, and c is approximately, nope, that's good, 19. I'm going to round it off to 19 though. 19.15? Okay. There you go. 19, that must have been why somebody corrected me last period. So let's say 19.2 units. Okay, so now that we know the length of side C, I'll keep the blue, I'll make all the numbers that we found blue. So now that we know side C is 19.2, how are we going to go from here?
Law of sine because you have the opposite angle on the side.
Yeah, I think most of us are going to, you know, prefer law of sine when we can. It's a little bit less work. So now that we know, like you said, that side and opposite angle, and we already have an obtuse angle. We can't have another one. Do you want to find? I mean, you're going to tell me what to write depending on how you're going to find A or B. So what are we going to do?
We are going 8 over the sine of A equals
8 over the sine of what?
A. Wait, no. 8 over the sine of B. 8 over the sine of B.
So we have 8 over the sine of B is equal to?
19.2 over the sine of 130.
Beautiful. Now what do you want to do?
Flip them.
Oh, you want to flip both sides. Okay, so we have the sine of B over 8 is equal to the sine of 130 degrees over 19.2
Wait, no.
multiplied by 8.
Yeah, multiply
Yeah.
by E.
So we have the sine of B is equal to 8 times the sine of 130 degrees over 19.2. And then B is equal to the arc sine, since I didn't write that a few minutes ago and threw somebody off. B is equal to arc sine of 8 times the sine of 130 degrees over 19.2. And B now is approximately, actually the whole thing is approximate because 19.2 is rounded off already, but 18.661. All right, so I'm going to make that 18.6. And we'll keep the found numbers in blue. Now one more time, how do we find the measure of angle A? Subtracting from?
Just kidding.
Subtract from, now I'm going to subtract from 180 degrees because it's the quickest way, but arguably the more, and there's kind of like no way around it to some extent, but the more you use the numbers you found through the problem, the more opportunity you have to make a small error continue forward. So if we do have this 18.6 wrong because we were doing it right but maybe just hit a number on the calculator wrong, if we do law of sine over again to find angle A, we will not carry a mistake farther through the problem if we find A not using 18.6 degrees. So there is some benefit to not, just, oh, I have 2, let's subtract from 180, because that error carry forward will happen less. 180 degrees, so 180 minus 100? 80 minus 30? 50 minus 10? 40, now 32 and 31, 4. Nice. Bam! I like the mental math. Okay, one more example. We got a triangle. Let's say this is 6, 4, and 8. That'll work. That actually makes a triangle. Okay, so for this triangle, what's the area? Now, if you don't have Heron's formula in your back pocket, you're going to have to do a lot of work. If you don't have Heron's formula in your toolbox, you are going to be forced to do the work required to find some altitude. Like if you only know 1/2 base times height, you're going to have to first do law of cosine. We know all three sides, so you can find any angle you want. But you would have to do law of cosine to find the measure of an angle. And then you would have to drop an altitude down and do the sine function to find the altitude of that triangle from some vertex of your choice. And then do 1/2 base times height. And 1/2 base times height, we talked about that the other day, is really built into this formula that kind of just does that automatically. But that's a lot of work. You don't have to do all that. Not if you've got Heron's formula. So how do we do this quickly?
It's 1/2, or S is equal to 1/2 of 8 plus 6 plus 4.
All right, so since I made these numbers different than last period, I think, 8 and 6 is 14, and 4 is 18, and half of 18 is 9.
And then it's
And then your area formula. Now this is going to look super easy, but I can tell you lots of people forget this formula and end up doing a whole bunch of work if they even try at all.
the square root of 9
Square root of 9 times
times 9 minus 8
9,
times 9 minus 6 times 9 minus 4.
6 times 9 minus
4.
4. And we have the square root of 9 times 1 times 3 times 5. 27 times 5 is what? 135. Okay, I changed these numbers, and that number's, I don't know if I can do that off the top of my head. I do, well, 1, 3 is 4. And this has a factor of 9 in it. Because 1 plus 3 is 4 plus 5 is 9. So I know 9 goes in here. What's 135 divided by 9? That's 1.
Math teacher. It's 4 and 5.
15.
15. Oh, we're smart.
Cool. 15? Yeah, 15. So this becomes the square root of 9 times the square root of 15. Do you guys remember that? If you're square rooting, if a number, if the digits of a number add up to 9, then 9's a factor.
Wait, really?
Yeah.
Wait, say that again?
If the digits in a number add up to 9, that number is divisible by 9. So the square root of 9 is what? 3 times the square root of 15 square units, and that's how you find the area of a triangle using Heron's formula. Bam! Go to your homework.